Earth and Mars were formed from inner solar system materials. This is by University of Munster on phys.org. Today's article, Earth and Mars were formed from material that largely originated in the inner solar system. Only a few percent of the building blocks of these two planets originated beyond Jupiter's orbit. A group of researchers led by the University of Munster of Germany report these findings today in the journal Science Advances. They present the most comprehensive comparison to date of the isotopic composition of Earth, Mars, and pristine building material from the inner and outer solar system. Some of this material is today still found largely unaltered in meteorites. The results of the study have far-reaching consequences for our understanding of the process that formed the planets Mercury, Venus, Earth, and Mars. The theory postulating that the four rocky planets grew to their present size by accumulating millimeter-sized dust pebbles from the outer solar system is not tenable. Approximately 4.6 billion years ago, in the early days of our solar system, a disk of dust and gases orbited the young star. Two theories describe how, in the course of millions of years, the inner rocky planets formed from this original building material. And according to the older theory, the dust in the inner solar system agglomerated to ever larger chunks, gradually reaching approximately the size of our moon. Collisions of these planetary embryos, finally produced the inner planet Mercury, Venus, Earth, and Mars. These planets were formed that way. A newer theory, however, prefers a different growth process. Millimeter-sized dust pebbles migrated from the outer solar system towards the Sun. On their way, they were accreted onto the planetary embryos of the inner solar system and step by step enlarged them to their present size. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. And here is our solar system, and the planets right next to the Sun are Mercury, Venus, Earth, and Mars, as you can see. And then we have the giants, gas giants after that. Now, both theories here are based on theoretical models and computer simulations aimed at reconstructing the conditions and dynamics in the early solar system. Both describe a possible path of planet formation. But which one is right? Which process actually took place? To answer these questions in their current study, researchers from University of Munster in Germany, the Observatoire de la Côte d'Azur in France, the California Institute of Technology US, the Natural History Museum Berlin, Germany, and the Free University of Berlin, Germany, determined the exact composition of the rocky planets Earth and Mars. We wanted to find out whether the building blocks of Earth and Mars originated in the outer or inner solar system, says Dr. Christoph Bernhardt of the University of Munster, the study's first author. To this end, the isotopes of the rare metals titanium, zirconium, and molybdenum found in minute traces in the outer silicate-rich layers of both planets provide crucial clues. Isotopes are different varieties of the same element, which differ only in the weight of their atomic nucleus. Meteorites as a reference. Scientists assume that in the early solar system, these and other metal isotopes were not evenly distributed. Rather, their abundance depended on the distance from the Sun. They therefore hold valuable information about where in the early solar system a certain body's building blocks originated. As a reference of the original isotopic inventory of the outer and inner solar system, the researchers used two types of meteorites. These chunks of rock generally found their way to Earth from the asteroid belt, the region between the orbits of Mars and Jupiter. They are considered to be the largely pristine material from the beginnings of the solar system, while so-called carbonaceous chondrites, which can contain up to a few percent carbon, originated beyond Jupiter's orbit and only later relocated to the asteroid belt, due to influence of the growing gas giants. Their more carbon-depleted cousins, the non-carbonaceous chondrites, are true children of the inner solar system. The precise isotopic composition of Earth's accessible outer rock layers and that of both types of meteorites have been studied for some time. However, there have been no comparably comprehensive analysis of Martian rocks. In their current study, the researchers now examined samples from a total of 17 Martian meteorites, which can be assigned to 6 typical types of Martian rock. In addition, the scientists for the first time investigated the abundances of 3 different metal isotopes. The samples of Martian meteorites were first powdered and subjected to complex chemical pre-treatment, and using a multicolored plasma mass spectrometer at the Institute of Planetology, University of Munster, the researchers were then able to detect tiny amounts of titanium, zirconium, and molybdenum isotopes. They then performed computer simulations to calculate the ratio in which building material found today in carbonaceous and non-carbonaceous chondrites must have been incorporated into Earth and Mars in order to reproduce their measured composition. In doing so, they considered 2 different phases of accretion to account for the different history of the titanium and zirconium isotopes, as well as of the molybdenum isotopes, respectively. Unlike titanium and zirconium, molybdenum accumulates mainly in the metallic planetary core. The tiny amount still found today in the silicate-rich outer layers can therefore only have been added during the very late phase, the last phase, of the planet's growth. The researchers' results show that the outer rock layers of Earth and Mars have little in common with the carbonaceous chondrites of the outer solar system. They account for only about 4% of both planets' original building blocks. If early Earth and Mars had mainly accreted dust grains from the outer solar system, this value should be almost 10 times higher, said Professor Dr. Thorsten Klein of the University of Munster, who is also director at the Max Planck Institute for Solar System Research in Göttingen. He says, thus we can confirm this theory of the formation of the inner planets, he said. Lost building material. But the composition of Earth and Mars does not exactly match the material of the non-carbonaceous chondrites either. The computer simulation suggests that another, different kind of building material must also have been in play. The isotopic composition of this third type of building material is inferred by our computer simulations implies it must have originated in the innermost region of the solar system, explains Christoph Bernhardt. Since bodies from such close proximity to the Sun were almost never scattered into the asteroid belt, this material was almost completely absorbed into the inner planets and thus does not occur in meteorites. It is, so to speak, lost building material to which we no longer have direct access today, says Thorsten Klein. The surprising find does not change the consequences of the study for theory of planet formation. In fact, the fact that Earth and Mars apparently contain mainly material from the inner solar system fits well with planet formation from the collision of large bodies in the inner solar system. This is what Christoph Bernhardt concludes. So this is by University of Munster and on phys.org. Please leave your comments and thank you for your support.